Good day everyone! Welcome back students! Once again, this is Doc Gilma, your grade 7 mathematics teacher. Last time I discussed about the different types of sets. This time I will be discussing the relations of sets. Are you ready class? So if you're ready, just sit back, relax, and listen carefully to the topic to be discussed for today. So let's begin. Relations of sets. Consider the following pairs of sets. We have set A and set B. Set A is equal to the set of all vowels in the English alphabet. Set B is equal to A, E, I, O, U. Notice class that both set A and set B have the same elements. Set A is written in the set builder notation, while set B is written in the rule method or listing method. This is simply an example of equal sets. When we talk about equal sets, it is simply denoted by A equals B, sets with the same elements. Take note. Pairs of sets with the same elements are equal sets. Consider again another pair of sets. We have here set C and set D. Set C is equal to the set of X such that X is a distinct letter of the word Gilbert. Set D is equal to the set of prime numbers less than 18. Take a closer look on the number of elements of set C. That's right, we have 7 elements, while set D have also 7 elements, which are 1, 3, 5, 7, 11, 13, and 17 are prime numbers less than 18. This is simply an example of equivalent sets. When we talk about equivalent sets, it is denoted by C if and only if D or C is equivalent to D. This pair of sets with the same number of elements or the same cardinality. Consider again another pair of sets. We have here set E and set F. Set E is equal to 1, 2, 3, 4, 5, 6. And set F is equal to the set of counting numbers. Take a closer look on the elements of set E and compare to set F. What did you notice class? That's right. The elements of set E are also the elements of set F. Set E is simply a subset of F. This is just an example of joint sets. When we talk about joint sets, it is denoted by E, a subset of F. E is a subset of F if every element of E is also an element of F. If E is not equal to F, then E is a proper subset of F. In symbol, E is a proper subset of F. Or in other words, class, when we talk about joint sets, these pair of sets have the same elements. It's not exactly the same, but they have at least one element in common. So take note of that. Consider again another pair of sets. We have here set E is equal to 1, 2, 3, 4, 5, 6. Set F is equal to the set of counting numbers. We can also say that this is simply a superset, a joint superset. It is denoted by F is a superset of E. If E is a subset of F, then F is a superset of E, since all elements of set E belongs to set F. Take note of that. Also take note, class, given any set A is said to be an improper subset of itself. Example, A is equal to 1, 2, 3. Thus, A is a subset of A. Take note, A is said to be an improper subset of itself. Number 2, given any set B, the trivial subset of B is phi or close and open braces, which is simply an empty set. Example, set B is equal to 2, 4, 6, 8. Thus, we can say that empty is a subset of set B. Take note of that. Consider again another pair of sets. We have here set M and set N. Set M is equal to 0, 2, 4, 6, 8. And set N is equal to the set of counting odd numbers, which are 1, 3, 5, 7, 9, 11, and so forth and so on. As you can see, class, set M and set N have no elements in common. This is simply an example of disjoint sets. These are sets having no common elements. So take note of that. Now, since we are done with our lecture, again, consider a simple mental exercises. Identify whether the following sets are equal, equivalent, subset or superset, or disjoint sets. Number 1. Set M is equal to the set of distinct letters of the word Mississippi. And set N is equal to C-A-R-E. What did you notice about the elements of set M? There are repeated letters. And what will you do with the repeated letters? Using the rule method. That's right. You have to write the letter which are repeated only once. So therefore, how many elements do set M have? That's right. It has 4 elements. So therefore, M and N are simply equivalent sets. Take note of that. Number 2. Set S is equal to 1, 2, 2, 3, 3, 3. Set T is equal to the set of X such that X is a counting number less than 4. So what are the elements of set T? That's right. Set T is equal to 1, 2, 3. How about set S? That's right. It has also 3 elements which are 1, 2, 3. So therefore, S and T are what we call equal sets. Take note of that. How about number 3? We have here pairs of sets Q and R. Set Q is equal to the set of letters of the word faith, and set R is equal to 10, 20, 30, 40, 50. How many elements do set Q have? That's right. It has 5 elements. How about R? It has also 5 elements. So this pair of sets is simply, yes, that's right, an equivalent sets. Number 4. Set K and set L. Set K is equal to the set of whole numbers. Set L is equal to the set of X such that X is a counting numbers greater than 10 but less than 100. Set K is the set of whole numbers. What are the elements of set K? We have 1, 2, 3, 4, 5 and so forth and so on. How about the elements of set L, which are counting numbers greater than 10 but less than 100? So we have 11, 12, 13 up to 99. So set L is simply a subset of K. This pair of sets are either subset or superset. Set L is a subset of K and K is a superset of L. Okay, take note of that. Number 5. Set H and set K. Set H is equal to the set of prime numbers. Set K is equal to 4, 6, 8, 9, 10, and 12, and so forth and so on. As you can see, class, these two pairs here have no common elements. So this pair of sets is simply a disjoint sets. Right? So we are done with our topic for today. I hope you have learned something from me. Next meeting, I will be discussing more about sets. Before we leave class, let me first read to you a simple passage from the Bible, coming from 2 Timothy chapter 4, verse 17. But the Lord stood with me and gave me strength. Take note, class, skills are developed through constant correct practice, and there will always be a room for improvement.